Okay, so tonight we're going to work on Unit 1-2, which is about measuring and constructing segments. Okay, so everything we do today is going to be about measuring or constructing line segments. So for the measuring part, I want you to, on your paper somewhere, draw a number line. Okay, so here is my number line, and I'm going to have 0 in the middle. 1, 2, I'm going to go all the way up to 5, 3, 4, 5, and then I'm going to go the other way, all the way to -5. So -1, -2, -3, -4, -5. So if you've got straight lines on your paper or a little ruler there, you can probably do at least as neat a job as I did with this. Now on this number line, I'm going to put a couple of points. So I'm going to put one right here. So this can be point A. I'll put one right here, point B, one right here, point C, and at 3, I'll put point D. Okay, what we're going to talk about is distance. Distance, and the word length is used sometimes also. Distance and length are interchangeable in this class. So when you see distance, length, they mean the exact same thing. And they basically mean how far apart. Okay, if something asks you what's the distance between two things or what's the length of something, it just wants to know how far apart they are. So let's say that I wanted to find what is the distance from point A to point C. I want to know what that is. Well, this is not an overly complex problem to deal with here. In the simplest terms, the easiest way you could do this is to just count the spaces. So I could start at A and I could count that it's 1, 2, 3, 4, 5. So the distance from A to C, just say that it's 5 units. Now that's pretty simple, not very exciting. But I'm going to show you a different way to do it. And you might think, well, why do I need a different way to do it? That just took me like 3 seconds to count that it was 5. Well, let's draw this same number line again. And I'm going to go ahead and put 0 on here. And I'm not going to put every number that goes in here. I'm going to skip a lot. So let's say that this goes from 0 to 1 million. And then it goes this way from 0 to -1 million. Okay. Now I'm going to put some points on here. I'm going to put a point right here. This point will be 367,285. And I'm going to put a point right here. This point will be -763,071. 763,071. Okay. Now, I'll put my points there too, so you can count your spaces. Okay, probably or hopefully right now you're able to see that it's not going to be very time efficient for you to count 763,071 times till you get to here, and then count 367,285 more times until you get to here, and the whole time keeping track of how many times you did this and how many times you went up and down with your pencil and keeping track of that. So hopefully we can find another way to do it. Many of you probably already know what the way is or have a good idea in your head. So let's go back over here to our point A and our point C. To find the distance between them from -4 to 1, we counted the spaces. But we could also find the difference between these two, the coordinates at these 2 points. So right here, this is -4, and for here, this is +1. Okay, and the way we would write this out, or the way we would show this work for this, is we would say that the distance from A to C, that's what this means. If I write A and C next to each other, that means the distance from A to C, or the length of segment AC. Notice I don't put a bar on the top. That means something different. So A and C with no bar on the top means the distance from A to C. Well, distance from A to C equals, we can subtract the two values, so -4 minus 1. Well, you should know that -4 minus 1 equals -5. And here's a mistake that a lot of people make, is they'll stop right here and say that, well, the distance or the length is -5. There's no such thing as a negative distance or a negative length, at least not in this class and not in the terms we're going to talk about distance and length. If you don't believe me, go out to the garage, get Dad's tape measure, and stretch it out -5 feet. Don't stretch it out +5 feet, stretch it out -5 feet. When you get bored with that, come back and start the video back up and I'll explain it to you. Okay, the number's correct, but the minus sign or the negative sign is what's hurting us. Now, the way we get rid of that problem is anytime we talk about distance, all we're concerned about is the absolute value of the difference. So hopefully you remember that absolute value means whatever is in between the absolute value bars gets switched from negative to positive. So the absolute value of -5 is 5. Okay, we could have also done the distance from A to C, and we could have used the absolute value of 1 minus -4. And you would know that that's the absolute value of 1 plus 4, which is the absolute value of 5, which is 5. So either way, we get 5. It doesn't matter which one of these two coordinates you use first, the -4 or the 1. As long as you have the absolute value, you're going to get the right positive distance that you need. Okay, so just remember, AC, no line on the top. Okay, the next thing we're going to talk about, along with measuring and constructing segments, is what happens when we have two segments that are the same length. So I'm going to draw two segments, and I'm going to use some little tools that you are not going to have, but it's okay. You can just do your best and make good notes, and you'll be okay. Everything will be fine. So I'm going to make a segment, and then I'm going to make another one that looks just like it, exact same length. I'm going to turn it a little bit so that it's not quite exact same spot. But I'm going to make this segment A, B, C, D. Okay, now you saw me create these segments, so you know that they're the exact same length. There's no doubt as to whether or not these two are the same length. Well, when two segments are the same length, they're called congruent segments. Okay, congruent segments like these can be written down like this. Segment AB, you know the symbol for congruent, is congruent to segment CD. Okay, and along with that, you know, or you should know, that congruent means same size and same shape. So we can also say that the distance from A to B is equal to the distance from C to D. So both of these facts right here are true because A and B is congruent to C and D. Segment AB congruent to segment CD. Now, the only reason you know that they're congruent is because you saw me make one and then use my computer to make an exact copy of it. Otherwise, you have no guarantee that these two segments are congruent. So what you're going to see in your problems is a little mark on the segment like this. Now, these are called tick marks. It's this thing and this thing. Tick marks are used to mark congruent segments. So, little example. This is a square. Okay. This is a rectangle, and this is an isosceles triangle. Okay, now in a square, what do you know about all the sides, all the segments? Each one of these is a segment, and you know that they're all the same length. So you'll see them marked like this. And that means this is congruent to this, congruent to this, congruent to this. They're all the same. Now in a rectangle, what do you know about the two sides of a rectangle? Hopefully you know that the opposite sides are congruent to each other. So this one is congruent to this one. Now this side is congruent to this side, but they're not congruent to these that we put one little tick mark on. So the way we differentiate between sets of congruent segments is to put multiple tick marks. Okay, so I have one here. That means it's congruent to every segment in the drawing that has one. 2 means it's congruent to every segment in the drawing that has 2. Okay, so then I come over here. I said this was an isosceles triangle. Well, a lot of times the way you're going to see that is you're going to see a triangle. It's not going to say it's isosceles. It's just going to have 2 little tick marks on it. Okay, the next thing that we're going to talk about with measuring and constructing segments is the 3 different ways that you can actually create a segment. So what I'm going to do here is I'm going to create a segment for us right now. So here's my segment. There's nothing special about it. I didn't make it a certain length. I just made it. Here's segment X, Y. Now, we're going to do 3 things with segment XY. Oops. We're going to sketch segment XY. We're going to draw segment XY. And then last, we're going to construct segment XY. Okay, out of the 3 of these, sketch is the simplest one. Sketch means I look at segment XY and then I try to make one just like it, just using my pencil. So segment XY is going to have an X. It is going to stretch out to a Y. And there is my attempt at making segment XY using the sketch method. Not bad. It's good for your notes. Sometimes it's okay in your homework. But if you're building a house or you're making blueprints or something like that, sketch isn't going to cut it. You're going to have to be a little more accurate than that. That's where we come to the draw. Okay? Draw basically just means you're going to measure how long this is, and what I'm doing over here is coming up with something I can measure it with. Okay, so here's a ruler. I'm going to put my ruler on my segment as best I can here. Alright, so now I say that segment XY starts right here at 0 and goes right here to 1 and let's see this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 14. This is 1 and 14/16, which you should know that's 1 and 7/8. Okay, so this segment XY, so from X to Y, is going to be 1 and 7/8. Let's see if I can get it to make a dot for me. Okay, which is right there. Get that out of the way. Use my little segment tool again. Put it right where 1 and 7/8 is. And then I'm going to put my Y there. Okay, not bad, right? Now, so I've sketched it, which is just basically freehand draw it. I've drawn it, which means I measured it and I tried to take that same measurement and redo it right here. The last thing I'm going to do is construct, and construct is the most accurate. Okay, the draw that I did where I just measured that it was 1 and 14/16, you know, maybe it wasn't 1 and 14/16. Maybe it was, you know, the width of a hair smaller, or maybe it was, you know, the width of a piece of paper bigger. But I can't tell that with that ruler I was using. It only goes down to 1/16 of an inch. Okay, the most accurate way to duplicate this segment is with a compass. Now that's what this is. And we're going to use these in class, and if you want to purchase your own, I think it would be a very wise investment. You can get one for a couple of dollars at Walmart. It'll last forever. and it'll be really beneficial. Now, the way you use a compass is you always have to start at a point. So I'm going to start with the pointy part of the compass on a point. So I put it right on the point. Then I'm going to extend the compass out until it is right on the other point. Now I have the right distance here. This is exactly how long it is from X to Y. So I'm going to come down here. I'm going to put an X. I'm going to bring my compass down here. I'll put it on my point X. And I'm going to use my compass and draw a little curved mark out here. Now I'm done with the compass. So I'll put it away. And I'm going to draw my segment that goes from point X, the exact distance. Now, it's the right distance no matter where I put it on this blue curve. That's something to do with properties of circles that we'll talk about much later in the year. But put it right there. I'm going to put my point Y. Now I've created a segment XY that is exactly the same length as this one was. We'll practice with those in class. Okay, there's two more things that we're going to talk about, and then we're going to be done. The first one is the concept of something being between something else. Okay, let's just say that I gave you a statement that said D is between A and C. Well, D is between A and C. You're going to see lots of problems that are written just like that. What that means is that there is a segment, and on that segment there is a A, there is a C, and D is between them. Now notice, I didn't put D in the middle. It doesn't say D is in the middle or halfway between them. It says D is between them. So I've done. D's between them. Fantastic. Okay, something that you're going to hopefully remember from going to school here in Alvin ISD is that the distance from A to D, that's this distance right here, plus the distance from D to C is going to equal the distance from A to B. And that's a concept that we've tried to teach you even back through elementary school. And hopefully this will look familiar. You should remember the phrase part, part, whole. And what that tells us is that this part plus this part equals the whole part. So if this part here, let's just for example, we'll write some numbers on here. Let's say that this was 3. That looks horrible. Let's say that this was 3. This was 5. You would know that this entire segment from A to C was 8, right? Because 3 plus 5 is 8. But we're going to write that down kind of in a math language instead of just saying part, part, whole. We're still going to say part, part, whole. But when you write this out, you would say that the distance from A to D plus the distance from D to C equals the distance from A to C. So AD plus DC equals AC. And this is called, this is something very important, segment addition postulate. You are responsible for memorizing how to do this. You're going to have to use it over and over and over throughout the year. It's never going to go away. And this is one of the things I would call a sink or swim type of item. If you don't make this connection or you can't work with this segment addition postulate, you're going to have a very difficult time in geometry. So make sure you understand this. I said there were 2 things left. That was one of them. So I'm going to separate these two with a line here. That was between, the concept of between. This is the concept of a midpoint. Okay? You may see something written like this. D is the midpoint of segment AC. So let's draw what that looks like. I'm going to draw a segment. So here I have AC. Now my D, I'm not just going to put it right here in between them anywhere I want. I'm going to do my very best to get it in the middle, right in the middle. And it's just for visual purposes here. It's not, nobody's going to come by and give you detention if you don't get it exactly in the middle. But the idea is that it's in the exact middle. So this is A, C, and then D is called the midpoint. Midpoint is another sink or swim, pass or fail kind of concept. You have to get this, and you have to get it quick. Okay, the midpoint is exactly halfway between A and C. And because of that, the midpoint does something to segment AC. It bisects it. Okay, now bi, like bicycle, bi means two. Sect, it's kind of like sections, right? So two sections. But it's not just into two sections, it's into two equal sections. Okay, so this segment, A to D, is exactly the same as segment DC. Now, if we know two segments are the exact same length, we know that they are congruent. Right? We also know that their lengths are equal. And the last thing that you need to know, and you need to stick in your brain, it's one of the most important things you can remember in geometry or recognize, is the way that you tell that this is a midpoint. Now up here it says D is the midpoint of segment AC, so it's kind of a giveaway. But you're not going to have a statement like this on most of your problems. What you're going to have are these two little marks. Do you remember what they're called? These are tick marks. The tick marks tell us that AD is congruent to DC, and therefore D is the midpoint of segment AC. So if you need to watch this section again, these last two parts, this is without a doubt the two most important things that we're going to cover in this entire unit before the first test. So make sure you understand between and midpoint.